Yeah. Oh,
Okay. Okay, welcome everyone to the Structural Engineering and Mechanics Graduate Program Info Session. My name is Richard Weeb. I'm a faculty member in the Structures Group. I'm also here with Eric Huberty. Eric, do you want to say hi?
hi, I'm Eric. I'm one of the graduate advisors here at University of Washington. If you can, if you're having trouble hearing us, please let us know in the chat. Throughout the presentation, as you have questions, feel free to jot them down in the chat and we'll read them at the end. And yeah, I'll let you take it away.
All right. Actually, can you, if you're hearing me, can you quickly send a chat saying all clear so that we know that folks are hearing what's going on? Hey, got lots of all clears coming through, so I suppose you can all hear me all right. Okay, so today I want to talk to you about our graduate program, why I think it's exciting, why we have a lot to offer for people who are interested in coming to the University of Washington. I think I'm going to talk for maybe 30 minutes, preferably, and then we'll have time for questions afterward. However, if you have questions as we're going through, please feel free to write them into the chat box, and if there are questions Eric can answer right off the fly, he will do so. Otherwise, we'll bring them up probably at the end.
Yep.
Okay. All right. So here goes. What is our graduate program all about? Okay. Okay. So this is us. This is all the faculty that are in the program. A bunch of names. I don't expect people to remember all these names. If there's a particular area of research that you're interested in, these slides are going to be posted. Some of our research projects are already posted online. Definitely reach out to us. But actually, the big key I want to emphasize from this slide, we're all smiling. I think everybody in the Structures Group is really easy to get along with. We really like the work that we're doing. And me in the bottom right corner over there, as the second newest member of the Structures Group, I can say I'm really proud to work with these folks. They're really excited about both teaching and research. They really like delivering a great student experience through our courses and helping our students get hired in great jobs afterwards. Okay, so a little bit of an overview before I get into courses, and I will get into the classes that we teach. A bit of an overview of what we are. The Civil Engineering Department has these 6 groups. We're up in the upper right, Structural Engineering and Mechanics. Doesn't mean you only have to take classes within that, within our group. We have geotechnical engineering, lots of students take classes there, construction engineering, and then also several other groups. And of course, civil and environmental engineering is only one department in the College of Engineering. We also have students take classes in all of these other different areas. So we offer many opportunities, both for your career as a structural engineer, but also to give you a good, well-rounded perspective on engineering. Okay, so today I'm going to go through the degree programs we have, the courses we have, and then questions, as I mentioned earlier. Okay, so the big division we have in the program is we have the course-based masters on the left. I think non-thesis program. The other name, I think the official name for it now is
Professional Master's Program.
Professional Master's Program, and on the right we have the Research Thesis Program. So the Professional Master's Program, to give you an example, right now we have 40 students. 30 of them are in the Professional Master's track. The other 10 or so, that's about the right numbers, are on the research side. So for the Professional Master's Program, you have to get 42 credits, and actually that's common to both. So the non-thesis or the Professional Master's Program, you need 42 credits, and that turns out to be 13 classes. That's because some of our classes are 4 credits, some are 3, but 42 ends up being 13 classes. Most of our students, however, take 39 credits plus 3 one-credit seminars. So that ends up being 12 classes plus 3 one-credit seminars. If you want to do a research thesis, you still need to do the 42 credits, but 9 of those credits come from a thesis rather than coursework. And I should mention, we do have students switching every year. Every year recently, we've had a student who thought they wanted to do a research thesis track, got here, served as a TA for several quarters, didn't want to end up on any of the research projects that were available, and ended up graduating without a thesis. And the one that is probably requested more often is going the other way. In recent years, we've had 1 or 2 students every year who started in the non-thesis program, also called the Professional Master's Program, and found a way while they were here to land a research project. I should say the research thesis program applications are quite competitive. The GPA and the scores that we see and the competitiveness for that one is quite a bit higher, and with good reason. It's quite lucrative. There's a tuition is covered, there's a stipend, so there's quite a few students that do want to do that, and of course a lot of people just want to get research experience. So it's competitive, but if you apply for the research track and you're not given that, we still consider every application for the professional master's track as well. Okay, so time to finish. I mentioned 12 classes for the professional master's program. If you wanted to finish your degree in only 3 quarters, we do have some students do that. That's a lot. So 12 classes divided by 3 quarters, 4 classes per quarter. So it's done, but it's tough. The students that usually are able to do that are students that have some transfer credits. And we do allow you to transfer up to 2 graduate courses for your degree here at UW. However, they must be classes that you do not need for your bachelor's degree, and they must be graduate classes. So they were courses above and beyond the credits that were required for you to get your bachelor's degree. 4 quarters is probably the most common. So mostly we have students who do the fall, winter, spring academic quarters, which is 9 months. Then in the summer, they'll do internships. There's a pretty large cohort of our students that do that. Then they come back for 1 more quarter in the fall to finish up. 5 quarters is also common, and even more than 5 quarters, especially for students working part-time. We have quite a few of those students every year. I already mentioned it, but that last point, I get questions about this every year with good reason. Many of our students do internships in their summer. Often those internships turn into full-time jobs. Often even if they have to come back and finish up a class or 2, they will just stay with the same company that they did their internship with. This is something I'm not going to spend any time on other than this one slide. We also, of course, offer a PhD. If you're interested in this is a much bigger discussion that you need to have with research faculty at some point. Be sure to reach out to folks, reach out to me if this is something you're interested in. But mostly, whether you're not sure whether you want to do a master's degree and continue on to a PhD or just do a master's degree, in many ways it doesn't really change the road that you need to start walking along right now, which is get your master's thesis first. At some point, that will transition into a PhD degree. Okay, so it usually takes 5 years total. That includes a master's degree. Honestly, I should say 5.5 years, not 5 years. And there's a few other steps along the way. You get your master's degree, you do a qualifying exam, there's more coursework that's needed, and a few other things. As I said, this is a big discussion you should be having with faculty if you're thinking about the PhD. Okay, so I talked about our 3 graduate programs, the professional master's program or the non-thesis program, and on the other side, the thesis program, and then the third one, which is a PhD.
Yeah. Can you hear us on this machine? Okay. Okay, we'll just have you talk right here.
Okay.
And you can direct
All
from
right.
that one.
So, all right, continuing on. I think I had just got to the classes, right, when I lost audio.
Does that sound right to everybody? The class overview?
Thank you. Okay, so these first three classes I should mention, 501, 502, 504, those are the only required classes. All of the other ones are electives. You can choose classes from these electives or outside of the structures group as well, and I'll talk about some of those. So these three classes, 501, 502, 504, are fundamental mechanics, and you do one in each of the first three quarters here. Okay, so 501. What is 501 about? Structural mechanics. I would say this is your stiffness method class, especially if you've had such a class like that before. Structural analysis, stiffness method on steroids. So we learn how to analyze beams, trusses, frames, stick structures like that, but we do it from a very robust fundamental formulation. So not only do we do the direct stiffness method, which is probably what you've done if you've done this before, but we do a lot of weak form variational method formulations, which is the biggest difference between undergraduate and graduate structures programs. And the things we teach here underlie finite element methods, which is another class, but we teach a lot of the fundamental mechanics underlying steps of finite element methods. The other core class is structural dynamics. This could also be called Earthquake Engineering 1 here at University of Washington. We have several dynamics classes. The other two are actually called Earthquake Engineering. This is the one in which you learn the fundamental mechanics underlying that. So not only do we have forces and deformations, we have inertial forces, mass times acceleration, and we have to solve the response of structures in time. This is a pretty classical class. You'll find this in every graduate program, I would say. And then the other one is the other core class for us, finite element methods. So I mentioned 501 was about stick structures, beams, and columns. Not every structure is like that. Some structures are complicated blobs of material. Even things that we think are stick structures like that frame connection on the left side are actually kind of really complicated 3D geometric configurations when you look close at the connection. So this class is about modeling stresses and deformations of complicated configurations like that. Another one that's getting more and more popular every year is engineering computing. This is especially as companies in the IT sector are growing. We're starting to realize there's a lot of opportunities for engineers to improve not only their algorithmic understanding of how structural engineering programs work, but also give them a perspective on the methods computer scientists use to write code, write algorithms, write user interfaces, and things like that. So this isn't just structural engineering. It focuses on structural engineering applications, but it goes beyond that to teach you more of the interfacing with a computer, using data, storing data, things like that. Okay, of course, I think probably most of your undergraduate students or recently finished a bachelor's degree at some point in recent history or in history. So you've often heard, while you're going through a derivation, a professor say, oh, let's assume the angles are small. Let's assume the strains are small. Well, at some point you can't do that anymore. So this class, nonlinear analysis of structures, takes it to the next level, which is the way real structures actually behave when you push them really hard. So you get geometric nonlinearities and you get material nonlinearities. And this class goes through a robust formulation of those aspects of structural engineering. Here's another class that I teach, structural stability. I remember when I was a student, an undergrad student, I had heard of buckling, Euler buckling, pi squared, EI over L squared, something like that, effective length factors. Well, stability and buckling is way deeper than that. It means a lot more than just buckling of struts. What about buckling of frames? What about buckling of 3D frames and 3D trusses? So this class covers those topics. Another class, materials modeling. In many undergraduate programs, you don't get too much beyond sigma yield, right? At some stress level, materials yield. Well, it also gets a lot more complicated than that. And this class delves pretty deep into the behavior of materials when you go past yield. What happens? How do the structures deform? Another important class is reliability and design. Real-world structures are real-world loads, especially, and material characteristics are not deterministic. The loads that our structures are subjected to and the materials they're built from have probability distributions. And this class tries to assess that properly. A big part of this class is teaching probability theory and then getting into the applications of how we can use probability theory to do things like assess what safety factors should be. Okay, so we've actually walked through all the analysis classes thus far. Now we're switching into design. And we would be remiss if we didn't have what everybody thinks a graduate program in structural engineering should have, which is advanced reinforced concrete design. This class goes beyond what a typical first reinforced concrete design class covers, because it covers things like distributed plastic moments, more advanced topics that are especially important in seismic engineering. Pre-stressed concrete design, we have a world expert here, Professor John Stanton, who teaches this class on pre-stressed concrete design. So this is, of course, ever more important as prefabricated structures and long-span bridges use this very commonly nowadays. And along with reinforced concrete, we have a advanced structural systems class. Oh, these are a little out of order, actually. Okay, so this class is not just a particular structural system. It's not steel, it's not concrete. How do you put the different structural components, beams and columns together to assess the structure as a whole system? We have gravity systems, we have lateral systems. This class does also cover something else that doesn't fit into all the other classes perfectly, which is two-way slabs, robust treatment of two-way slabs. Advanced steel design, this is the one I was thinking of when I saw the previous slide. This kind of has to go hand in hand with advanced reinforced concrete. Every graduate structural engineering program really ought to have these two material systems. So this class gets deep into steel design, especially in earthquake regions. How do we use concentrically braced frames, even other systems, eccentrically braced frames, buckling or strain braced frames will even be covered. So state-of-the-art look at steel systems in seismic regions. Then we get to another class that I suppose actually could be in our analysis side too, which is Earthquake Engineering 1. This could be called Structural Dynamics 2. So this class looks at how do we design equivalent lateral force method and other approaches to take a really complicated phenomenon like buildings in an earthquake and turn that into a design of a building. This is very important for us in Seattle. This is why I think we have perhaps more earthquake engineering courses than many other programs. Maybe a few of the other schools on the West Coast will have this as well, but we're very proud of our offerings in earthquake engineering. While Earthquake Engineering 1 is oriented a bit more toward how do you actually design buildings nowadays, Earthquake 2 is how are we going to design buildings in the future. This class has more of a researchy take on it. We look at open seas modeling, look at advanced models that go beyond prescribed code approaches. Wind engineering, likewise, this one goes beyond what most engineers necessarily do in practice, which is rather than use prescribed building code wind loads, let's get them ourselves. Let's do computational fluid mechanics, and let's try and first understand the mechanics of wind loading, and then use our understanding to get loads on complicated structures for which we don't necessarily trust the building code standard equations that are given. Bridge engineering, this is a course we've used to teach a lot, but it fell away in the last 2-3 years. We're really happy. We're starting to offer it again every year. Again, in Seattle in particular, we've got all sorts of crazy bridges all over the place. I'll bet a lot of you at some point have seen a video of Galloping Gertie. That is a dynamically unstable bridge that's very near and dear to us here in Seattle, but we've got all sorts of floating bridges in Seattle. We're surrounded by water, so it's a great place to do bridge engineering. And bridge engineering also overlaps a lot with construction engineering. There's a lot of not just structural problems, but construction problems, logistics problems when you're trying to build something like this. And you have to do it quickly so you don't interrupt traffic. And then, well, apparently I lied earlier. I said I'd gone through all the analysis classes. There is one more analysis class And in fact, if you were to join us next year, this one would not be offered. This one and stability, which I talked about earlier, are offered in alternating years. In the upcoming year, stability will be offered, and this particular class, elasticity, will not be offered. If you stick around through the summer into a second year, then you would have a chance to take this as well. If you're interested in a thesis, that would likely be the case. So this class also extends beyond stick structures. It goes into arbitrary 3D blobs of material so that we can characterize the fundamental deformation behavior, the fundamental deformation, strain, stress behaviors of arbitrary solids. This class, I would say, is actually kind of a fundamental foundation beneath finite element methods. Finite element methods 504, the class that we teach every year, covers how do we actually solve such problems. This is a class that provides the foundation of understanding for why does finite element methods work? Why do the answers we get make any sense at all? Lastly, I mentioned that many of our students will, rather than taking 13 classes, will take 12 classes plus 3 seminars. We've got a wide variety of seminars. Some examples are the bottom left, structural engineering practice. I think every winter quarter we have firms from downtown Seattle, MKA, KPFF, CPL, come in and give presentations. It's a networking opportunity. Many of our students end up working at those companies. Those are high-flying, exciting sorts of companies that build high-rises and bridges, not just here, but around the world. Other quarters, we do things like research presentations, department-wide seminars where you can get a little more well-rounded and learn about environmental engineering and other things outside of structures. And another seminar we've been doing the last couple of years in the fall quarter is quite popular. It's a counterweight to a lot of the theory we do in our other lectures. It's a seminar on approximate methods of analysis to get ballpark answers. It's something that's important for every engineer, especially as we move forward into quantitative, exact, finite element computer analysis. That's great. But if you're just talking to somebody and you're trying to ballpark this geometry and size of a structure, it is good to still have some of those classical approximate methods. And this is something that I don't expect you to remember offhand, but feel free to take a screenshot or we'll post this. If you're thinking about how you're going to set up your schedule and what would a degree at UW look like, these are the courses we're actually offering this year. Next year, I suspect it will be similar. You'll note we don't actually have anything listed in the summer right now. We have a summer course offered every once in a while. Do you know if we have one offered this year?
I don't know. It's usually decided last minute.
Yeah, the summer class is decided. Yeah, we don't always have it. In some sense, many of our students go do an internship, which also means the demand isn't always so high either. But every once in a while, we've had an advanced steel 2. I don't think you'll see that anywhere else on the list. So we've taught an advanced structural steel 2 before in the summer. Every once in a while, the bridge engineering class has also been taught in the summer. And when we do have a class like that in the summer, sometimes the interns come and show up for that class anyway. They're interning somewhere, but they have an agreement where they can still come take a class. This is another option, replacing one class with maybe you're in the professional master's program, but you'd like to learn a little bit about what research is like. So this is an opportunity that it seems every year a student or two will also take advantage of. So you will pair with one of the faculty, you will take a 3-credit independent study course and work on a research problem with that faculty member. The main challenge here is matching up with the faculty member. They may not always all have time. This is kind of on a volunteer basis for them in the sense that it's not a research project that they have funded. But on the other hand, this is also often the sorts of pet projects they're really interested in and don't have funding for, but sometimes they jump at the chance to have a student do work for them in an independent study on this project. So it can work well for both parties, but it requires a bit of matching. Okay, so I think I've talked about the courses that most folks are interested in when they're thinking of, I want to do a structural engineering graduate degree at the University of Washington. I like the West Coast, I like earthquakes. But we do require, I think, at least one class be outside of structures. And some students want to take a few more. So we have here's a list. There are many more online as well of classes outside of our department. Some of our students especially like advanced foundations, infrastructure. There's all sorts of project management classes that students can take, construction management classes that students can take. And for me personally, my research is more on the aerospace structures side. So I often have students, especially my thesis students, taking classes in mechanical engineering, aerospace, material science, applied math. Here's a few other classes students like to take. Okay, so it's pretty open. And we say we require one class outside of structures. If you want to take 3 and they make sense for you, if they align with your interests, let's say you have a internship with a drone startup, and I use that example because one of our students had that, and the student said, you know, I'm a structural engineer for them, but they do composite structures. Can I please take some more classes in composites? Absolutely. That's a structural engineering master's degree. That makes sense for you to not take as many concrete and steel classes and instead take a composites class. So that is something I definitely get asked every year. And that example is probably one of the most common interest in taking composites classes. So that is the formal program that I had to go over, but I'm happy to answer. Hey, I hit my target of 30 minutes. I'm happy to answer any questions.
So yeah, hopefully you see at the bottom there's a little chat bubble. Feel free to type some questions in as they come up. We'll stick around for a bit until all your questions are answered.
And by the way, the picture you see right now, it's a nice picture. I don't think it quite does justice to the real view that we have here. Maybe not today because it's probably raining.
Yeah, not today, but it is a pretty special view. Okay, so the first question we have is, who should I contact about transfer classes? The way that process generally works is when a student is admitted, they'll work with me or one of the other graduate advisors to kind of do an analysis of what on their transcript is eligible. Usually this requires getting some kind of documentation from your prior institution, either like an advisor letter stating that it wasn't used toward an undergraduate degree. And then every student who is part of our program has a kind of staff advisor like myself, and then a faculty advisor who's the content area expert. And what they'll do is they look at, we'll go over the syllabus and help us identify the kind of relative class that we also offer. And then as long as that faculty advisor approves it, we have to submit some paperwork in the form of a petition to the graduate school. Usually it's not much of an issue, especially if we have faculty support for that. So, you know, it's something that can get done in your first quarter. Do you want to tackle that one?
Yeah, sure. And the next question is mechanics of plates and shells taught in any of the analysis classes? If so, which one? It's taught in the structural systems class, but that's for reinforced concrete, two-way slabs. It's also taught in the elasticity class, fair bit. The unfortunate timing is that class will not be taught next year. The other avenue I'd really recommend, and I don't think UW is the only place where we would do this sort of avenue, would be an independent study. So plates and shells are a personal interest of mine, and I would be very happy to advise a student on an independent study on a class focusing entirely on plates and shells. I think you'd get a lot more out of it that way because it would be focusing on that one topic. It would probably go beyond linear plates and shells into nonlinear deformations. And I say all this because I've done it before with another student who was interested in that topic. So I think we're open to getting pretty in depth into that topic. I hope that answered your question. We have another question.
Yep. So if you're interested in the PhD, should you reach out to faculty before or after admissions? Do you want to speak to this? I always say before admissions is obviously very important, but maybe in terms of what kind of questions should you be asking? What is there appropriate best way to do this?
I would say it's great if you reach out to us before. Another thing that a PhD is a big decision. I'd also recommend you go and talk to faculty at your current institution right now. It's a lot to discuss. I mean, when I was a student, I wasn't quite sure even what I didn't know that I didn't know about doing a PhD. So you can certainly reach out to us about projects. I've already had several students contact me and email me, and it helps if you say, look, I'm applying to the University of Washington, because we get a lot of emails every day from students who are prospective, and I just don't have time to reply to them all. But if we know it's a student that's applying to the University of Washington, really wants to come here and just wants to know more about our graduate program, yeah, it's totally fine if you email us faculty beforehand about the PhD. I'd also say at this point, I mean, you're applying based on the record you have right now. Whether you're applying for a PhD or a master's, don't worry too much about game theory. Should I change how I write my application? You're just representing yourself. Don't worry too much about changing your application and thinking, oh, if I say PhD, I have a better chance to get in than if I apply for the master's. I don't think so. But that's not really how we do our admissions.
Great. We have a question about GRE scores here. This is pretty specific, but if you applied to a different department at UW with your GRE scores, you shouldn't need to resubmit them formally. What I would do is contact the graduate school at UW grad, G-R-A-D, at uw.edu. They'll make sure that those scores are linked, or you can email me directly at ceginfo@uw.edu. That's kind of our general advising email and a good point place. I can go in and look up and see if the computer program is tracking those scores as well. And if not, we can work and try to get that sorted out. That shouldn't be a big deal. You should only have to submit it once. When will we know if we got into the thesis program? Do you want to talk about the timeline, or?
Do you remember when we got them out last year?
Yeah, so usually it's like the first week of May is when offers with funding and admissions would go out. Usually, that's last year we had a bunch of snowstorms, so things kind of got delayed, and I realize snowstorms is a terrible excuse, but if you've ever been to Seattle in the snow, you understand. Usually, though, we really aim for that first to second week of March.
And I'd add to that, one thing that happens in many years is, say we don't have the offers out yet, but some of the students that have applied have offers from elsewhere. They will reach out to us and say, look, we've got this offer from another school. They've given us a deadline. We'd still like to know if we got into the University of Washington. Can you kind of fast track or give us an update? And absolutely do that. Don't be shy to reach out to us, both Eric or me or any of the structures group, about letting us know that you've got a timeline. So we're quite accommodating for that.
Are courses ever offered in mass timber?
That is a wonderful question. So mass timber is a growing, really hot topic in structural engineering. I'm proud of the work we're doing, and on the research side here at University of Washington and mass timber, we've got excellent research going on in rocking mass timber structures. Unfortunately, we don't offer a class in mass timber right now. Hopefully that will change. But to counter that, I would say regardless of the material system, steel, concrete, timber, you'll find our program and a lot of the other top programs in the country focus on fundamentals. So we want to produce students that understand fundamental mechanics and are happy to switch between materials. Of course, there are differences in materials. Of course there are, but we have, especially if you get into the thesis side, we have many opportunities for mass timber research going on. Yep. Thank you, Clara.
Any other questions out there? What other opportunities to connect with current PhD students? This one's a little tricky, mostly because of FERPA rules, which is, general privacy. My suggestion has always been, if there's a specific area of research that you're really interested in, reach out to the faculty member who is kind of leading the charge in that area, and they can reach out directly to PhD students if they're willing to connect. You can say, hey, look, I'm, really want to kind of know what research is like as a PhD student, and maybe they can facilitate that. But it has to be something that a student opts into.
I was just wondering about that. Great question. Good question, Jesse.
Yeah, the question is, does UW host a visit day for those admitted? I'll let you take that away.
Yeah, we have a visit day every year, and this upcoming visit day will be February,
It's sometime in February.
mid-February. And during that day, it's also great that you asked this question, because one of the big parts of that day is meeting our current graduate students. They present their work, they go out for dinner and drinks afterward, and you get to learn everything from them about the university. And of course, the whole day you also have many opportunities to meet with us.
Yeah, and that is a limited invite visit. I think invitations to those usually come out by the end of January. So if you have questions, feel free to let us know. Last year, ours got snowed out for half of it, and it still went great. So hopefully that will not happen again this year, even though it was really pretty.
How many visitors did we have last year for instruction?
Oh,
30?
Maybe 30, maybe 25, something like that. So.
And in the last couple of years, we have started admitting not only students interested in, that have indicated interest in a thesis track, but also students that have indicated an interest in the professional master's program. What's the name of that mountain we see in the picture, everyone?
Yeah.
Yeah.
Okay, any final questions? It seems like if there are any good process questions about the application, I'm happy to answer them. If there are any more general program questions, you can always reach out to us. Again, the kind of prime email address for all your grad questions, and I can route them, is ceginfo@uw.edu.
I have one other selling point. I think we're at pretty much a 100% hiring rate for our graduate students after the master's degree.
Yeah.
And many of them, for example, we had a student last year who had job offers from KPFF, MKA, Degenkolb, one other company, 4 job offers. And I mean, that's not the only story like that. Our students are getting really great job opportunities at companies that build world-class structures, high rises around not only Seattle, but San Francisco, Chicago, New York, Philippines, China, Taiwan, you name it. Companies from Seattle, the big companies I've listed, are bidding on those contracts. They're known worldwide. They have an excellent reputation. And not only that, our students are getting hired at companies around the world as well, companies in San Francisco, in Chicago, in New York. So I'm really proud to teach in the department that I teach in. I think we offer a lot to our students, and I hope that came through in this talk, and I'd love to have you all apply to our program.
Do you have TA-ships, and do those help funding the education? How do you apply for that? So anybody who is, and feel free to jump in if I get anything wrong, but anybody who applies to one of our research tracks is automatically considered for an RA, TA, fellowship, etc. Any kind of funding source. We primarily, I think we strive to only admit PhD students and master's thesis students with funding. And so if we have money for specific projects, then you'll get an offer. The professional master's program is self-pay. It is a credit, pay per credit type of program. So what that means is that it's a flat rate. There's no in-state, out-of-state, international tuition, which is kind of nice. Yeah.
I can add a bit to that too. I think I mentioned we have 40 students this year. 10 of them are on the thesis track. 30 of them are on the professional master's track. Of those 10, 3 of them came in with a project. That meant over the summer they had already been talking with faculty members. Actually, even during the admissions process, they had been talking with faculty members, and they had already matched up on a project. But the other 7 were really competitive applications. We had, in the whole structures group, we knew we had at least 7 projects. So we brought in 7 students, but we don't typically assign them to a project from the get-go. Some students really like that. They want to be able to come here. They want to be able to take classes for a quarter, and then match up with a professor after they've met all of us. And of course, you get a chance to meet us during the visit as well. But some students really like that opportunity to have a quarter here as a TA in their first quarter, to meet and greet faculty, talk about research projects. And then typically in their second quarter or third quarter, they will transfer from a TA to an RA. So that's our typical admissions process. We admit students that we know we have funding for in the RA-TA pool, and then they switch from TA to RA at some point.
Yeah, so the next question we have is it possible to be admitted to a fall quarter but essentially deferred to a later quarter? On the graduate school side, the logistics side, that is something you're able to do up to once for up to a year. So if you were admitted in fall 2020, you could defer to fall 2021 or any time in between. I don't know in terms of sequence of classes, is there a major issue with starting in an off quarter?
One of the challenges is that the 501 class teaches the stiffness method, which is pretty central to a lot of the other classes. I think it's not the end of the world if you don't come in and take that right from the beginning. I'd say that's the sort of thing you could send me an email and we could look at the courses you've taken and see if that makes sense and if you'll be behind the 8 ball or if you will be able to keep up with that kind of approach. So it could be done, but I'm not quite sure.
Great.
Any other questions? Okay. Thank you all very much.
Great. Have a good rest of your evening and let us know how we can help. Take care.